important unit, which is a practical unit, that is SQL, stands for Structured Query Language. And coming to the importance of this is, it is an Oracle database. We are going with the Oracle database with a language SQL, that is a structured query language with Oracle database. Practically in industry while doing mini projects and mega projects, capstone projects, you will be forced to work with the database, and you need to know about the database concept. And also in these days, you might have listened about big data, data science, data analytics. Right, students, will go ahead with the SQL queries, that is structured query language queries. Here, we are going to discuss about the relational algebra, and of course the selection statement, projection. The projection of relational algebra we are going to do with the select statement. With the select statement, I'm going to demonstrate what is projection, and set operators, and division operations, and the combination of operations. This is what we discussed in our previous class with the relational algebra. The same concepts I am going to demonstrate in SQL. The recap of the previous program. In the previous class, we discussed about the relational algebra. We discussed about the selection operation, projection operation, set operations, that is a union, intersect, and difference, division operation, and join operations. That is the multiple tables, extracting the data from multiple tables with the help of join operations. This is what, and also the combination of operations. This is what we discussed in our previous class. Now, in this class, let us have a discussion on SQL, introduction to SQL, importance of SQL, what is the importance, why we need to make use of SQL, the select statement with where clause, that is the conditions, how to make use of conditions, logical operators, how to make use of logical operators, AND operator, OR operator, NOT operator, and of course you are having multiple tables, how to extract the data from multiple tables, that is the join operations, and select with expressions, mathematical expressions. We can write some mathematical expressions with select statement, and with string formats, how to work with string formats. This is what we are going to discuss in today's class. This should be the outcome of today's class. And coming to this SQL, third unit, SQL queries, constraints, and triggers. SQL queries, constraints, and triggers. Coming to the SQL, it contains the three important factors. One is queries, another is constraints, another is triggers. These are the three major predominant features of SQL. That is SQL queries, constraints, and triggers. These are the predominant features of SQL, stands for structured query language. Structured query language SQL is the most widely used commercial relational database. It comes to the commercial relational database language. It comes under the commercial relational database language. It was originally developed by IBM International Business Machines in SQL. It is being initially named as SQL. Later, the SQL is renamed as SQL, stands for Structured Query Language. The initial name of the software is SQL. Then later it was renamed as SQL, stands for Structured Query Language. It was developed in between 1947 to 1977. In between 1947 and 1977, this was developed. It was developed with the basic foundations or the fundamentals of DBMS, database management system. As I told you previously, the relational algebra concepts are being introduced, and with the help of relational algebra concepts, this SQL is being developed. Nowadays, it is a de facto standard that every programming language, in order to have a backend, they make use of SQL queries, that is a structured query languages they use. SQL continues to evolve in response to changing needs in the database area. There are different versions of SQL. We worked with 7.2, 9, 10, Oracle, 10G, I11i, different versions. Depending upon the needs, as the needs are getting increased day by day, depending upon the needs, the SQL is evolving in different shapes and formats. So this is all about the importance of SQL, or the introduction of SQL. It was initially called as SQL, SEQUEL. The initial name of SQL is SQL. It was developed in between 1947 and 1977. In between, later it is renamed as SQL, stands for Structured Query Language. Structured Query Language. It was developed by W. Chamberlain at St. Joe's Research Laboratories. And coming to the overview of this, SQL language has several aspects in it. The different aspects, why SQL is so important, because it contains various aspects, several aspects which are not available in other languages are being incorporated in this. It is having different aspects, several aspects. What are those aspects? It supports the DML, that is data manipulation language. Suppose I want to insert a new row, you can do that. I want to delete a row, delete a row. I want to remove a row, yeah, you can do that. And of course, I want to do some modifications, updations. I want to do some updations or the modifications, you can do that. So insertion, deletion, modifications. Insertions, deletions and modifications can be done comfortably with the help of a DML, data manipulation language, which is a part of SQL. DML is a part of SQL, structured query language. This is the language. In SQL, you are having one part called as a DML, stands for data manipulation language. There is another part called as a DDL, stands for data definition language. So all these DML and DDL both comes under SQL, structured query language. So in order to work with instance like inserting data, to delete the data or to modify the data, we make use of this DML, stands for data manipulation language. Similarly, you have DDL, stands for data definition language. If at all I'm interested to construct a schema creation, dropping the schema or modifying the schema, you are interested to work with the schemas, then you go with the DDL, stands for data definition language. DDL stands for data definition language. Coming to the data definition language, first the schema is to be created. The structure is to be created. Once the structure is created, then into that structure I can store the instance, that is the data can be inserted. In order to create the tables, in order to create the views, in order to delete the tables or views, or in order to alter, that is a modification of tables, then you use separate commands which comes under the DDL command, stands for data definition language commands, DDL commands. And of course, not only tables and views, you are having even the concept of index. There is even a concept called index. And coming to this index, it is used to increase the speed of processing. Suppose from a system I want to see 1,000 records. In a system there is data and I want to see 1,000 records. 1,000 records I want to see. In a system there are 1,000 records I want to see. It may take some time to fetch the required records, to choose the required records, to filter and to project. It may take some time. In order to avoid that, in order to increase the speed, in SQL, you are having the facility of creating index. You are having the facility of creating index. So with the help of index creation, you can just create index. You can just create index and the speed of processing gets increased. The processing speed gets increased. That is the purpose of index. So with the help of DDL, that is a data definition language. With the help of DDL, data definition language, you can create tables, you can create views, you can create index, tables, views, index. You can create all this stuff. After creation of table, I want to delete the table, I want to modify the table, you can do that. So all this is possible with the help of DDL, stands for data definition language, which is a part of SQL. DML, DDL, these are all the part of SQL, stands for structured query language. And it is also having the facility of triggers, advanced integrity constraints. It is having the facility of triggers and advanced integrity constraints. And coming to the triggers, they are condition. Whenever an event occurs based on the specified condition, the triggering activity gets activated. That is you observe here, actions executed by DBMS whenever changes to the database meets the conditions specified in the trigger. That is, we propose some action. We will say that this action is to be performed when this condition is satisfied. Listen carefully. We will ask the system to perform some action, some activity. I'll request the system to do some activity, some action. That action is to be done based on the condition. I'll put a condition. If this condition is satisfied, then do that action, I will say. If this condition is satisfied, then only do that action, I will be specifying. Accordingly, that action gets initiated. That's called trigger. Of course, we will be working with triggers. Practically, I give demonstration on triggers. So here in SQL, you are having the facility of triggers. And also it is having integrity constraints, advanced integrity constraints. We discussed about these integrity constraints. Already I explained you about the integrity constraints previously. Primary key, unique, not null, foreign key references, on delete cascade. All this comes under the integrity constraints. It is having some advanced integrity constraints. So that is another benefit of SQL, why it became so popular. That is, it is supporting triggers, it is supporting advanced integrity constraints. And coming to the SQL, it is having embedded and dynamic SQL facility. Embedded SQL and dynamic SQL facilities are there. Embedded SQL features allows SQL code to be called from the host language such as C, COBOL, etc. That is nothing but it is called as an embedded SQL. In C language, I use SQL queries and I will try to execute the database. In Java, I will be using SQL commands and I will try to pull the data from the backend. That is called embedded SQL. So in other programming languages like C language, C++, Java, Python, I make use of SQL statements. I utilize SQL statements and that Python can enjoy the results. Inside the Java I use SQL statements, so the Java can enjoy the advantage of the backend. That is called embedded. You can embed these SQL statements in other programming languages, which is called as embedded SQL. You are also having a facility of dynamic SQL. There is a facility of dynamic SQL. Dynamic SQL features allows the query to be constructed at runtime. So at the execution time, I can construct the queries as per my requirement. I'll demonstrate. There is a concept called ampersand. With ampersand, you can construct the dynamic SQL. That is nothing but the query can be constructed at the execution time. At the runtime, I can create a query at runtime, at execution time, which is called as a dynamic SQL. The SQL is providing two facilities. One is embedded SQL, the second is dynamic SQL. This is a very advantage to the end user. Client server execution and remote database access. So a client machine can be separated from the server machine. I can connect 100 clients to one server, single server. And all the 100 clients, when they are entering the data will be pulled into the central server. When 100 clients are entering the data, the data which is being entered by the 100 clients will be pulled up in the centralized server. Similarly, the data which is centralized in the server can be extracted, can be taken, can be visualized by all the 100 clients. That is, the client server architecture is available with SQL. Remote database accessing. Remote database accessing means the database is kept in a remote location in the servers, and only the persons who is having the accessing rights, they only can access the data. The persons who are having the accessing rights can only access the data. They only can access the data, and no other unauthorized users can't access the data. So this is the other advantage of SQL. So it is having the client server execution and it is having the remote database accessing facilities are there in SQL. These are the reasons why SQL is so popular. You observe here, it is having the facility of transaction management. Various commands allows the users to explicitly control aspects of how transaction is to be executed. When the set of statements are activated, previously I told you atomicity. When there are some set of statements, all the set of statements are to be executed completely, otherwise no statement should get executed. If executed, the complete transaction should happen successfully. Otherwise, the entire transaction should be failed and it is to be aborted. So that is nothing but transaction management. One activity is, I want to perform one activity. In order to perform that activity, let me say there are 10 statements of code. If executed, all the 10 statements should get executed successfully. Otherwise, all the 10 statements should get aborted. That is, they should get failed. This is how the transaction management takes place. Similarly, it is having logins, passwords, securities, roles, privileges, and all that security concepts are there. SQL provides mechanisms to control users' access to data objects such as tables and views. For tables as well as the views, view is also a concept of security. In a table, you are having a lot of data. This data is visualized by all, but I want to prevent that. Then I'll create a view on table. Already we discussed about these views. We create a view on table. So through view, if you see, only the required data is visible and rest of the data is kept hidden. So with the help of tables and views, you can provide security. And of course, with the help of logins, passwords, privileges, roles, you can provide security. And it is also having advanced features. SQL is having advanced features, and advanced features like data mining concepts, spatial database, text database, that is satellite images of Earth, satellite images, that is a spatial database, text database, XML database, and all these XML data management concepts, all these are available, is possible with the help of SQL. So these are all advanced features. Because of all these advanced features, the SQL became so popular. Today we are learning SQL, though it was developed in 1974 to 1977 in between by Chamberlain. Even today we are working with SQL. The reason behind this, it is having all these features. The features are DML, DDL. The features are DML, data manipulation language, DDL, data definition language, DML, data manipulation language, DDL, data definition language. You are having triggers, advanced integrity constraints, embedded and dynamic SQL, client server execution, remote database access, client server execution and remote database access, and of course you are having transaction management, security and advanced features. Transaction management, security and advanced features, some other advanced features like big data analytics, data mining, spatial data, and all these advanced concepts are there. Because of all these concepts, the SQL becomes so popular and it became a de facto standard of the IT industry that every project should make use of SQL. So this is a bit introductory stuff on SQL. Now let us go ahead with some queries of SQL. Before going to the queries of SQL, dear students, before going to the queries of SQL, you please remember these side headings: data manipulation language, data definition language, data manipulation language, data definition language, triggers and advanced integrity constraints, embedded and dynamic SQL, client server execution and remote database access, transaction management, security, advanced features, transaction management, security and advanced features. So these are all the features of SQL, and hence the SQL became so popular. Now let us start from the basic SQL queries. Suppose in the table, in a backend, in your disk, there is some table called sailors. There is a table called sailors. In your backend SQL, there is a table called sailors. And also there is a table called reserves. There is a table called boards. There are three tables, three tables available in your disk. Listen carefully, there are three tables which are available in the disk: sailors table, reserves table and boards table. Sailors table, reserves table, boards table. All these three tables are available in the disk, in the hard disk. I want to see the data. I want to see the data. Then Select asterisk. You observe here I am using asterisk mark. When I say select asterisk from sailors is the name of the table. Sailors is the name of the table. Select asterisk from sailors, semicolon. Select asterisk from sailors, semicolon. Then automatically all the details of sailors, all the details of the sailors. Asterisk means the complete information. Asterisk means all columns. Asterisk means all columns. You will get the complete data, all columns data from the sailors. From the sailors table, you will get the complete data. Similarly, I want to see the reservations. These sailors has reserved some boats. For example, 22 is a sailor ID. He reserved boat number 101. He reserved boat number 101 on so and so date. So this is a reservation table. I want to see complete details of this table. Then I should say select asterisk. Asterisk means all columns from reserves. From reserves, you'll get the complete data of this table. Similarly, here there is another table called boats. The name of this table is called boats. I want to see the complete details. Select asterisk from boats. When I say select asterisk, asterisk means all columns. The meaning of asterisk is all columns. I want to see all columns from boats. So this is the data which will be projected. Boat ID, boat name and color of the boat. Boat ID is 101 and the name of the boat, boat name. Boat name is Interlake, it is blue color. 102 is a boat ID, Interlake is a boat name, red color. Boat ID is 103, Clipper and it is green color. Boat ID is 104, Marine and it is red color. Marine and it is red color. So select asterisk from sailors means you will get the complete details of sailor. Select asterisk from reserves means you will get the complete details of reserves. Select asterisk from boats means you will get the complete details of boats. Just 1 minute, you please glance at this query. Query 1, 2, 3. Please study the queries. Select asterisk from sailors means you will get the complete data, all columns of sailors. Select asterisk from reserves. You will get the all columns of reserves table. Select asterisk from boats. You will get all columns from the boats table. Select asterisk from boats means you will get all columns data. All columns data from boats. Asterisk from sailors, asterisk from reserves, asterisk from boats. The complete data of these tables will be listed out. That is this. This is the syntax. Select distinct, select selection list from list. This is the table list. From list means table list where qualification means condition. Select selection list. I am using asterisk. Asterisk means I'll get complete information from list. From where? You want from sailors. From sailors table. Sailors is the table. Select asterisk from reserves. Asterisk from reserves means I want all columns. From where? From reserves table. From reserves table. Select asterisk. I want the complete columns. From where? From boats table. Get this. So this is regarding the select statement. Now, just we'll go through this. Select, find the names and ages of all sailors. The question is, find names and age of all sailors. Name and age of all sailors. I want name, I want the age of all sailors. Select distinct of all sailors. I am introducing a word called distinct. Distinct will avoid duplicates. If you want duplicates, don't use distinct. You focus on distinct. If at all I use distinct, duplicates are eliminated. If I don't use this distinct, you will get duplicates. If I use distinct, duplicates are eliminated. If I don't use distinct, duplicates are allowed. That's the thing. Select distinct s.name, s.age from sailor S. Select distinct s.name, s.age from sailor S. The sailor table is being called as S. This is optional, not necessary. Here it is not necessary. Even if you use, there is nothing wrong. The sailor table, I am calling it as yes. The sailor table, I am calling it as yes. From sailor, select distinct s.name, s.age means sailor's name, sailor's age. From sailor, the sailor table is being called as yes. This is projection. I am projecting names and age. Names and age. Dustin, age. Brutus, age. Lubber, age. Andy, age. Rusty, age. Horatio, age. Jorba, age. Art, age 25.5. Bob, 63.5. You got age. You are getting only names and age. Here you are specifying select distinct name and age. Select distinct name and age. So you are getting names and age of sailors from sailors. You are getting names and age of sailors. That's what you are getting. Now you observe here names and age of sailors. Observe carefully. If you see the original table, here in original table you are having Horatio 35. If you observe this, you are having Horatio 35. Here also you are having Horatio 35. Horatio 35. So name and age are getting duplicated. I am asking to project name and age. Name and age, Horatio 35, Horatio 35 are getting duplicated. But in output, if you observe here, you are getting only one Horatio 35. You are getting only one Horatio 35. You are not getting two Horatio 35s. In table, you are having Horatio 35 and Horatio 35 twice. But in the table, output table, if you observe here, you are having Horatio 35 only once. That implies because of the distinct, the duplicates are eliminated. Find all sailors whose rating is above 7. I want only sailors whose rating is above 7. What I am doing, select s.sid, sailor ID, sailor name, rating and age from sailor as yes, or you can say sailor yes. There is nothing wrong, sailor as yes. In the previous example from sailor yes I am saying. Here from sailor as yes, both are one and the same. Where S dot rating is greater than 7. The ratings should be greater than 7. I want only those. This is your original table. Rating greater than 7. I want only those whose rating is greater than 7. Rating greater than 7 is Lubber. Greater than 7 is Andy. Greater than 7 is Rusty. Greater than 7 is Zorba. Greater than 7 is Horatio. Only these ratings are greater than 7. So select ID, sales ID, I say sailor ID, sailor name and rating of the sailors and age of sailors from sailor table whose rating is greater than 7. Where rating is greater than 7. Rating greater than 7 is Lubber. If you observe the original table, this is the original table. Lubber. Rating is greater than 7, Lubber. And hence you got Lubber, the data of Lubber. Here Andy. So you got Andy. In the output you got Andy. You are having Rusty. In output you got Rusty. Here you are having Zorba. Output you got Zorba. Here you are having Horatio. You got Horatio. Please go through these two queries. For this is the output. For this is the output. This is the original table. Please go through this for a minute. You please go through. Right. Let us proceed. With where clause, we can make use of relational operators. Less than or equals to, not equals to, greater than or equals to, not equal to. You can use less than or equal to, not equal to, greater than or equal to, and equal to. And also you can make use of the logical operators, and operator, or operator, and not operator. You can just make use of the operators, logical operators, and operator, or operator, and not operator with where clause. And also I told you the distinct keyword. The distinct keyword is optional. You may write, you may not write. If you write, you will not get duplicates. If you write, you will not get duplicates in your output. If you don't write, you will get duplicates. Similarly, after from, you can write the table name along with a range, or we call it as alias. That is yes, sailor yes, from sailor yes. I am saying that yes is nothing but it is called as a range variable, or we call it as alias. We call it as a range variable, or we call it as alias. Range variable or alias we call it. That is about the select clause. So in the basic select clause of the syntax of SQL query, from is followed by table name. Table name is followed by a range variable, or we call it as alias. You can write expressions with the select statement. Of course, with where clause you can check the conditions and you can perform horizontal fragmentation. When you use where clause, you can make use of the logical operators, AND operator, OR operator, NOT operator, and also you can make use of the relational operators, less than, greater than, less than or equals to, not equals to. And of course, there is a distinct keyword. There is a keyword called distinct. There is a keyword called distinct keyword. There is a keyword distinct. To avoid duplicates, we use this distinct. So these are all are the operators which we use with the select statement. Let us work out with some more queries. You observe here. Let us work out with some more select statements. Select sailor names, age. He is asking to select sailor names and age. Age. Whose age is in between 30 and 40. The age is lying in between 30 and 40. Now, for this is the question. Find sailor names and age. I want names and ages of those sailors whose age is in between 30 and 40. Select name, age from sailors. Select name, age from sailors. I want name and age from sailors. Where age is greater than 30 and age is less than 40. I am using logical operators and I am using relational operators. Here you can observe I am using relational operators. Greater than 30, age greater than 30 and age less than 40. It should be greater than 30 and compulsory. Age should be less than 40. Select followed by the column headings name, age from sailors, name, age from sailors, where age is greater than 30 and age less than 40. So age greater than 30 and age less than 40. Age greater than 30 and age less than 40. So you will get those sailors whose age is in between 30 and 40. You get the sailor names whose age is in between 30 and 40. If you observe, this is the original table. This is the original table. From the original table, you are getting Brutus because the age is 33, in between 30 and 40. Rusty, 35 years. Horatio, 35 years. Horatio, 35 years. These are the sailors whose age is lying in between 30 years and 40 years. The rest of the sailors you are not getting. This is the original table. From the original table, you are getting this as an output. I want to make use of OR operator. Just I want to demonstrate OR operator. Find sailor names whose rating, age, sailor names, rating and age whose age is less than 40 or rating greater than 8. Either this or that. Whose age is less than 40 or rating greater than 8. Whose age is less than 40 or rating greater than 8. And if you observe here, the rating is greater than 8 or age is less than 40. Rating is greater than 8 or it should be greater than 8 or age is less than 40. Age should be less than 40. So here you should not get this. Rating greater than 8 or age is less than 40. You should not get this. You should not get this. Why? Rating should be greater than 8. It is not. Or age is less than 40. No. So this Dustin, this is the wrong output. You should not get this. You should not get this. Rating is greater than 8. No. But age is less than 40. Yes. So this is right. This is right. Rating greater than age is less than 40. Here age is 25 years. This is right. Rating is greater than 8. This is right. Horatio, age is less than 40. This is right. Jorba, rating is greater than 8. This is correct. Horatio, rating greater than 8. Correct. You are getting this. Art, rating is only 3, but age is less than 40. Age is less than 40. Age is less than 40. Yeah, age is less than 40. Age is less than 40. You can have that. You will not get destined. You will not get destined. The first row, you will not get destined. Rest is correct. Perfect. In the previous query, here I am using, in the sixth query, I am using AND operator. In this query, I am using OR operator. I am using OR operator. There I used AND operator. Here I am using OR operator. Once you please go through these two queries. Please go through these two queries and the select statement. This is Oracle statement. This is Oracle select statement. I'll give practical demonstrations with SQL query. Yeah, please go through this. Hope you had gone through this. Fine. I'm proceeding to the next one. Slowly I'm introducing joins. Already we discussed about these joins like conditional join, equi-join, natural join. I'm just going with the join operations. I'm introducing the join operations. Find the names of sailors who have reserved at least one boat. Find names of sailors who had reserved at least one boat. Let me say this is one relation. This is sailors. These are reservations. This is sailors table. This is reservation table. This is sailors table. This is a reservation table. Sailor table and reservation table. These are the two relations. Sailors table and reservation table. Now he is asking names of the sailors who reserved at least one boat. If this sailor has reserved, definitely his sailor ID will be in this table. Here in this table you are having sailor ID, name, rating and age of sailor. If at all he reserved a boat, his sailor ID will be here. Sailor ID 22, he reserved boat ID 101. 22 also reserved 102. 22 also reserved 103. 22 also reserved 104. Sailor ID 31 has reserved 102. 31 has reserved 103 boat. 31 has reserved 104 boat. Sailor ID 64, that is Horatio, 64 Horatio, he reserved boat number 101, boat number 102, and 74, that is Horatio, 74 Horatio, he reserved this boat. 64, he reserved this boat, and 64 also reserved this boat. 31, he reserved this boat. 31 has reserved this boat. 31, that is Lubber, he reserved this boat. Means 31 has reserved three boats. 22 has reserved this boat. 22 has reserved boat number 102, 101, 102, and 22 also reserved the boat 103. 22 also reserved 104. Also reserved 104. This is nothing but join. There is nothing but join. Now, from sailors, reserved. When I say sailors, reserved, sailors, yes, reserve R. Sailor table and reserves table. Where S dot sailor ID should be equal to R dot sailor ID. S dot sailor ID equals to R dot sailor ID. S dot sailor ID should be equal to R dot sailor ID. This 22 got connected with the 22 rows. This 31 got connected with 31 rows. This 64 got connected with 61 rows. This is where clearly specifying S dot SID. The SID of sailor, S is representing sailor. The sailor's SID should be matching with R, reserve's SID. Reserves, R SID, that is the reserve's SID. So this 22 got connected with this 22 and so on and so on. From this, I am asking to project only names. I want only names. I am interested only in names. This 22 is nothing but Dustin. How many boats? Dustin has reserved 4 boats. And hence you got Dustin, 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 and Dustin. Similarly, the 31 has reserved 3 boats. Who is 31? That is a Lubber. So for Lubber, Lubber, and Lubber. 64 reserved 2 boats. Who is 64? Horatio. You'll get Horatio and Horatio, the names. 74. Who is 74? 74 is again Horatio. You got Horatio. 74 is Horatio. You observe here, Dustin has reserved 4 boats and 4 times you got the name. Lubber has reserved 3 boats, 3 times you got name. Horatio has reserved 2 boats and another Horatio has reserved 1 boat. And hence you got output like this. Suppose I don't want the duplications. Means here you use a distinct. If you use a distinct here, then duplicates will be eliminated. That is the purpose of distinct. Duplicates gets eliminated. That should be S name. Okay. Just a minute. You please go through this query. We are using equi-join here. The sailor ID of S table, that is the sailor table, should be matching with R means reserves. Sailor ID of reserves table. Just please go through this for a minute. Hope you had gone through this. So I am joining multiple tables and I am extracting the names. Let us proceed to the next concept. joins, select sailor IDs, select sailor IDs of sailors who have reserved red boat. Sailor IDs who had reserved red boat. So the sailor, I want the name of the sailor who reserved red boat. You observe here, reservations are in reserve table. This is a reserve table. This is a reserve table. And boat colors are in another table, that is a boat table. Here you are having two tables. One is boats table, another is reserves table. Your question is, you want the sailor IDs. You want sailor IDs. Only IDs he is asking, he is not asking names. He is asking sailor IDs of sailors who have reserved red boats. So if you observe here, the red boat is 102. 102 is a red boat. 104 is a red boat. 102 is red boat, 104 is red boat. What I am doing from boats B and reserves are B dot boat ID equals to R dot boat ID, where B dot boat ID should be equals to R dot boat ID. I am joining these two based on this. B dot boat ID should be R dot boat ID. R is reserves table. So 102 and 102 gets connected. 102 because why I am taking 102, that is a red boat. 102 and 102 gets connected. 102, 102 gets connected. 102 and 102 gets connected. 102 gets connected. 104 because 104 is also a red boat. So 104 and 104 gets connected. 104 and 104 gets connected. 104, that's all. That's all. 104 is reserved by 22. 104 is reserved by 31. 104 is reserved by 31. 104 is reserved by 22. Now you observe here, he is asking the R dot SID. For these rows, you choose the SID. SID is 22. For these rows, you choose SID 22. So you got 22. Here you are having 31. You got 31. You got 31. Here you got 64. You got 64. Here you got 22. Here you got 22. Yeah, this 22. Here you got 22. 104, 22. So you got 22. 104 with 31. 104 is with 31. You got 31. 104 is with 31. So 22, 22, 31, 31 and 64. These are the SIDs. These are nothing but SID. That is a sailor IDs. These are the sailor IDs. So you are extracting the sailor IDs of those sailors who had chosen red boat, who reserved red boat. So this is a reservation table, this is the boats table, and we are joining these two tables and we are extracting the data. This is how you are getting the output. Dear students, with this I would like to conclude today's class, and any doubts you feel free to ask me. Any other interactions, any doubts, you feel free to ask me. We just commenced the third unit. Today we commenced third unit, that is SQL. Third unit is full of SQL. And lastly we go with the functional dependencies.